like the binary file handling. I think I did explain it properly and did diagrams. Yeah. If I'm not mistaken, I did explain it. Yeah, so I'm not going to touch on the diagrams again. So let's do question 2. Okay, we need to do the whole import thing and stuff, so let's do that. Let me remove this question paper. Move this, then no, and then go back here. Okay, I need to create the project. So Eclipse, I should have opened it a long time ago. But it's okay, we'll wait for it. So I'm gonna need to copy, paste all of these files. Yeah, if you think you're gonna survive semester test 3, okay. You think slides are gonna help you with semester test 3? Semester test 2 is easy to pass. You can even get 100, easy. But semester test 3, that one is a beast. That one you need to fight. Did I add him? Okay, you need to fight with that one. So reading the textbook, and they don't give you the textbook for design patterns. They don't. They just show you weird examples, shortcuts. That's the example. Then when it comes in the test, they'll be like, decide which design pattern to use, and then follow up question, explain why you chose that one. Follow up question, show a demonstration of that. Hey, our design patterns are not nice. Semester test 3. Then you have those little principles. Then what else? There's also another theory for semester test 3. I forgot the other one. But yeah, if you're used to cramming and taking shortcuts, it's not going to end well. Let me close this. Okay, Eclipse has its own issues. So let me close that. Close project. Then I'm going to create a new project, Java project. Then I'm going to name it, right? So Vortex Academy 2024 ST2 question 2, right? Then I'm going to save it. I don't want to have to struggle to locate it. But if I save it there, I'm probably going to delete it. Let me just choose this so that I don't delete it by mistake. And then finish. Then expand this, then go to our additional files, select all of them, right click, copy them, go to your Eclipse project, right click on the name of the project, and then paste it. Then overwrite all. Then done. So this is our files, right? So we have everything. Then we go back to our PDF. Then now we need to start, right? So question 2, problem modeling and binary processing. Problem statement. The company, dystopian factories need to automate the processing of facility data. So just automating the processing of data. That's all we're doing here. Basically, instead of you doing things manually, you just click run and then it reads the file. It does things automatically. Currently, the data is stored in a binary file format using only primitive types. This is what sets apart boys from men. Only primitive types. That must tell you something. If you don't, I read. If that makes sense. I hope I'm saying it right. So we need to understand binary file handling, right? So binary file handling, but okay, let's talk about file handling in general. We always gonna make use of the file class in Java, right? And then we pass this file class, it accepts Java. This file class, right, it accepts the constructor, it accepts the name of the file. Why do we have to pass it via file class? Because Java might get confused and think, no, you're referring to some string. You shouldn't be confused. So for example, your file is factory large.txt, right? So if this is your file, if you just leave it as a string like this, Java might think, oh, you mean the string factory, blah, 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 .txt. And you don't actually mean the string, you mean the file. So that's why we have to pass it inside a file class. So the file class, its main purpose is to establish a connection between the file. So what do I mean by connection? It's like for your phones, right? For example, Bluetooth. If you remember, or a speaker, whatever, Bluetooth. For let's assume it's like your speaker, right? Let's just make that example. Let's say your speaker, you take out your phone, you open Bluetooth. The moment you switch on the speaker, it automatically switches on its Bluetooth. Then you establish a connection to the speaker. Then it's gonna say Bluetooth is connected successfully, right? That's weird. What? Then it says that to tell you that the connection has been established successfully. So the same concept with Bluetooth, we apply it here. That's the whole purpose of a file class, is to establish a connection between the Java application and the file. But then since that's the only purpose of the file class, we don't have methods to read and write from to and from the file. So we don't have those methods. We cannot read or write to and from the file. So we need separate classes to do that. That's why we end up creating separate classes for that. So I hope that kind of makes sense. So since we're establishing a connection, right? The connection might fail to be established. The only reason it would fail is because the file does not exist. So after creating the instance, I know I haven't taught you about that. We're going to use it in this practical. You can do an if statement to say if, let's say you have a file and say it's equals to new file, right? And then it takes in this thing, the name of the file via the constructor. Let's say you're creating it as a separate variable because you want to check, you want to test if the file exists. So you can say file, there's a method called exists, right? You can say dot exists to check if the file does actually exist, meaning we were able to establish the connection to our file because the connection to the file can only be established if the file exists. For example, you can't connect to a Bluetooth that does not exist, right? So it needs to exist. So that's why there's a function called exist, which just checks if the connection was established successfully. Once we have established the connection, then we can read from the file, right? Or write to the file. And it depends what type of file it is. We talked about files that you can store a file in plain text, right? But then the plain text is not actually plain text because computers, remember we talked about computers in the first session, right? When you're doing intensive revision. Computers are very stubborn. They only speak their own native language, which is binary digits, right? Zeros and ones, or machine language. That's the language itself. So since it's stubborn, how does it work with text files? So the way text files work, right, is if you go here, let's say you go to downloads, let's say you have, okay, I don't see a text file here, but any file, let's say PDF, right? I think PDF would be a very good example. If you right click on PDF and you open it with Notepad++, you get surprising information. You see, that is not actually text. You see, this is binary. This is binary. This is language of the computer. That's why I'm going to teach you some extra stuff. That's why each file has an extension so that it's opened by the right program that can decode those bytes, right? Remember, we talked about encoding and decoding. A text file uses encoding and decoding, but sometimes that makes the file become slow, like reading and writing from the file becomes slow. So for example, if it's stored as this binary number, let's assume that's hello world, something like that. It gets past, it goes through a process called decoding, right? Basically converting it from binary to a char or to characters, or in our case to strings, but then it's a char. So it looks at each and every single symbol, and then it converts it and decodes it to a char. But then the decoding process, right? Remember, it has to convert it to an integer first. So binary to integer type because remember we talked about ASCII and Unicode. So it needs to convert it to its code point. They're called code points. That's the right Java term for it. They're called code points. Basically, it's integer representation. Then once we have its integer representation, we convert it to the actual character itself. So for example, it's a full string hello world, right? So this would be this process is what we call decoding, basically undoing what we did when we write into the text file. Then to write to the text file, basically vice versa, we call that encoding, right? So that means there's actually technically no such thing as a text file because it's stored under the hood as a binary file. But then the operating system looks at the extension of the file. Then you open it with the appropriate program that can be able to do the decoding. So here, hence here, when I open this diagram, right, you see I'm opening it with Adobe Acrobat. So that means it has decoded. It knows, oh, you mean stack, grandparents' house, blah, blah. Now it's converted to text into a human readable form. But it's actually still stored as binary. So there's no such thing as text file. So don't get confused by that. There's no such thing as text file. So this whole process of decoding and coding, it wastes time. It makes it makes the reading and writing to the file slow. So sometimes you might want to work with the raw data, right? It's gonna sound wrong, but sometimes we just want to go raw, right? So we just want to work with the raw data. So with the raw data, it's kind of it removes all this part of decoding and coding and makes it fast because we store it in default form, which is the language of the computer, which is binary. We store it in binary, then we just simply read those binary those binary digits, right? Those bits. Then we create an instance. If it's an instance, if it's variables, then we store it into variables. So we remove this decoding and encoding process, this part, to save time, right? To make our files faster. In the industry, I think they use binary. Yeah, they use binary files to store things. They don't use text. Text is rarely used. Yeah, because text file it's very prone to cyber attacks. So cyber security. So you can't use text files. So most of the time you're gonna store things in binary. That's why you also taught by file handling in school, because that's something you're gonna do practically, like in the real world. So we understand that part. We understand that a file class does that, the binary files, we understand that. Let's also talk about the different types. Remember, the file class does not have methods to read and write to or from the file. So we need to have separate classes that deal with that. So, so the person who is not muted, who's that? As I was explaining, right? I'm gonna explain this one more time. If next time for some weird reason there's someone who's unmuted and things like that, I'm gonna kick you out. So because I don't understand, maybe English claps you. I don't know. Like you can't be that slow. You're doing comp sci 2A, you can't be that slow. Like you can't read things. When you join the meeting, it shows you an option. Do you want to switch on the camera or you want to switch it off? Do you want to activate audio? You want to switch off audio? It shows you there. So you need to make sure those two options are off, or else you're going to be kicked out and watch the recording. Because it sometimes this thing of background noise, because someone you are students, you have roommates. Maybe it's quiet at that point in time. Then someone enters, it's like, hey, Maubane, hey, we're chowing, what. We don't need to know all those details. You see now, we're hearing things we're not supposed to be hearing. So next time I'll kick you out if I see random people unmuting. So as I was explaining, the file class does not have methods to read and write from the file. So we need separate classes to do that. So that's why we have extra classes. So we're gonna have a class. We have classes called file input stream, right? File input stream. Then we have the class file output stream, right? So these two classes, the main important part you need to focus on is the input stream part and the output stream part, right? Then the file, it means is the input stream linked to the file handling part. So hence it's file input stream because we are doing file operations, right? We are working with files. We are not working, it's not system.in. Remember, system.in is also of type input stream. That's why they added the file part there to distinguish, so that you know that this is not the console input. This is file input. This is file output. And then it does it via what it calls streams. So file input stream, file output stream. So file input stream, right? This is to receive bytes of data from the file. And then this is to send bytes of data to the file. That's their purpose. So the main thing you need to understand, right? They send it to a what? To a file. So that's why we pass a file instance when we instantiate this to classes, right? To instantiate these two instances of that class. But then you see what I'm talking about here? We said bytes. And I remember another word for 1 byte is equals to 8 bits, right? Which is basically a sequence of 8 zeros and ones. Bit stands for binary digits, and then we have 8 of them. So basically 8 zeros and ones. So for example, 2, 4, 6, 8. So example this would be what we call 1 byte. If you have another set of 1 byte, this is now 2 bytes, and so forth. So that's what you mean by bytes of data, meaning it's, in other words, basically zeros and ones. So if this file class is right, they read the raw zeros and ones. How am I going to output it to the user? The user won't understand if you say see out this. The user doesn't speak machine language. So how do we fix that? What we can do is we can I'm gonna use this word, but I wouldn't advise you to use that word because you might get confused, but I'm gonna use it to kind of get the point across. So we wrap these bytes inside variables. We wrap them inside data types, right? Or inside data types. Yeah, let's say data types. We're gonna wrap them inside data types. Basically, if this was a number, let's just assumption, right? Let's assume this was like a 20, this was like a string hey. So we wrap them into data types so that they're in a human readable form, right? So basically the term human readable form, you can use it on both binary and text files, because at the end of the day, text files are binary files, but then they go through this process of encoding and decoding. So don't think you've passed the paper by seeing human readable form. They might put it under a binary question, and you think, perfect, let me do regular expressions for a binary file. If I saw you, I would kick you out of the vein. I would say, Chief, question 2 is not your thing. So comment out errors and zip and submit. Leave the vein. Don't waste your time, because you're gonna get 0 for that question. So since this is a problem, the human or the person using the program or the app, even though it might not look like it, we're actually making an app here. This is an app. Don't get confused when I say app. We're actually making an app. It's just that it doesn't have buttons, but it's still an app. So this app, right, that we're going to create is going to be used by some user. So this user needs to be able to read and understand what's going on. So if it displays the zeros and ones, they don't speak the machine language, right? So you need to wrap this into data types or primitive types. So there's 2 ways we can wrap it. We can wrap it into primitive types, or we can wrap it into reference types, basically objects or reference types. So we're going to have 4 sets of classes, right? We have data, input, stream. Then we have data, output, stream, right? Then we have object, input, stream. Then we have object, output, stream, right? So we have this. But then remember that there's also the concept of buffering. It might not look like it's important, but buffering speeds up the process. Or else, why do I say speed up? Or else you're going to press run here, right? For now, these are small files. Imagine if they were very big and you're given a prac to solve this. You would press run here and you would wait maybe at least 2 minutes before it shows you output. Imagine waiting 2 minutes to see output simply because you didn't use buffers. So that's why most of the time we're going to buffer our data. And then the way we buffer our data depends on whether we're getting input. So if we're getting input, we pass it via the buffered input. If we're outputting, then we pass it via the buffered output. So therefore, we're gonna have this class is buffered input stream, and then buffered output stream. You might ask yourself, how am I able to remember all of this? I use common sense. I don't cram things. So if you look at this, we look at what's common here. Input stream, output stream. Input stream, output stream. Input stream, output stream. So there's no need to cram. Cramming, that's when it goes down and you start doing spiritual things. So the file part means this is related to file handling, to files. The buffered part means, oh, it's a buffer, it's related to buffer, meaning this is how I refer to my buffer. And then data. Primitive types is what we call data. So data is another word for primitive types. So I know, oh, this is for storing primitive types. And then object. How can you create an object? From a reference type, basically from a class. So I know these two functions are related when I'm reading or writing objects. This is for reading or writing primitive types or data. So this is for primitive types, right? Primitive types, and then this is for reference types, right? Basically, if the question says you need to write the objects to the file, they said objects. So you need to use object input stream or object output stream. But since you are writing, that means you are outputting. Let me also teach you terminologies, right? So that you know that you see that there's no need to cram. You have a file here, right? When you read to the file, let's say this is some file, right? When you read from that file, right? Reading from the file. When you read from the file, what do? You receive data, right? So for example, reading from the file, it's like extracting. You can read, not reading wouldn't be the right terminology for it. The word I would rather use is extracting, but we just say reading from the file. But you're literally extracting. So for example, you go to do blood donations, right? And then they extract your blood. They're sucking out the blood. They are having access to that thing. So to the person who's draining your blood, right? Since you're going there to donate blood, that person who's draining your blood, we can say that person is receiving it. So to him, it's like input, right? So this is done via the input stream, right? Because we do everything via streams. It's input and it's done via a stream. So therefore input stream, because we're receiving it. Then writing to the file. Writing to the file is basically sending text to the file. That is one and the same thing. Writing to the file is the same as sending text. So that means it's going to be output. So basically the file is we're gonna output something to the file. So basically if I type this, right, if I say hello world, right, to say hello world, this is me outputting to the file because I don't know how come students get confused. If you remember this, right, let me create a main class here. Trust me, don't worry about me not taking my time. Question 2 is short. That's the easiest question, to be honest. Question 1 is the difficult one because you need to, if your regular expression is, if there's any mistake, maybe you code the next token extra 2 times, crash. Your pattern doesn't work, no display, no output. So that's the problem with question 1. It's actually difficult, more difficult than question 2. Question 2, you just need to understand buffer, streams, all those things. So if you remember to output something, right? I say system.out. Come on. Why is it? I need to get a new laptop. And then hello world, right? This is the same. You see, we're using the word out because it's outputting. We are sending it out to a console. This is the system.out, right? Part is linked to the console. So print, right? You see, there's the so that even though you see it's displayed on the console, right? We use the term outputting, right? So it's being sent via the output stream. So that's the same concept, but then now it's related to files. So hence this term here, file output stream. It's still the same output stream, but now we're outputting to a file. So file output stream. But then this only sends bytes of data. We want to send so we might want to send primitive types because in obvious our program works with variables, right? So we're gonna send variables, not binary. We're not gonna send binary. So that's why we need to pass it into these functions, into these classes, I mean. So this is the same as writing to the file or outputting to the file. So we output to the file via what we call an output stream, right? So that's the whole concept. But that's why there's so many input stream, output stream. That's what it means. There's nothing fancy about it. The only difference is the first word in the word before the input stream or the word before output stream. It describes the thing we are outputting or inputting. So object, I'm inputting an object. That's basically I'm receiving objects from a file. And then output object, it starts with objects, meaning I'm outputting objects. And then data here is primitive types. So this is the flow. You create the file instance, right? Because we need to establish a connection to our file first, or else Java will think you are referring to a string and not a file. So we need to establish that connection, sort of like Bluetooth connection. Because think about it, in order for you to send a file to the next person, what do? You connect via Bluetooth first, right? Then after connection is established, then they tell you, oh, send me that picture. Then they click and send that picture from their phone to your phone. In this case, the two phones, you can picture them as a Java program and the file itself. So Java needs to create a connection or establish a connection with the file before we can send to or from each other. Reading from the file, it means I'm receiving a file or receiving information. For example, I'm receiving a file from my friend via Bluetooth. For me, that will be passed via my input stream because I'm receiving it, right? It's input for me. And then writing to the file, it's me sending a file from my phone to his phone. So it's going to be output. It's going to be sent out to him, to his phone. So that's the simplest way I can explain it. You don't understand that? Hey, I don't know. Nami, I give up on you too. I don't know if you don't understand that explanation. So we establish the connection first, then we need to pass it via the file input stream and file output stream. Because why? Remember our file is a binary file. So we need to be able to read and write those bytes. So file. So let's say you're reading from the file, right? Let me put a comment here. Let's say you're reading from the file. So you're reading from the file, right? So you pass it via the file input stream because we don't have methods inside the file class to read and write to or from the file. So you need to pass it via a class that can read from the file. But then this class only reads bytes, which won't be useful to the user. We need to wrap it around another class that this class, what its main goal is to take in a file input stream instance and then wrap it around primitive types. So I need to pass it via, it depends on what you're reading. So if you're reading data or let's say data or objects, right, from the file, then there's two ways. If you're reading data, you use data input stream. If you're reading an object, you use object input stream because I'm reading an object via the input stream. But then before we pass it into data, so this would be, you can actually, to be honest, your code will run. I don't want to lie to you, there won't be any issues, but you won't get full marks. You can skip the buffering part, like don't pass it into a buffer, you can skip it. But it's not gonna run, it's gonna give you full marks, right? There's people who don't care as long as they get 50. Some people are they just accept being mediocre. To me, that's actually accepting being a mediocre person, and you never get a proper paycheck being mediocre. So you must always strive to be a perfectionist. That's how you even get paid more, because they'll be like, yeah, you're worth our time. You put in effort to understand things and not just do the bare minimum. So it starts now. There's something called habit. It starts as a small thing and it becomes a habit. So don't do that. Be a perfectionist. Do everything. Don't skip things. So this would be fine, but this is incomplete because if the file is too big, you realize that the app becomes slow, it jams. You think maybe there's a network problem, Wi-Fi or something, but there's not Wi-Fi, there's no Wi-Fi problems. You just didn't buffer it. So you need to pass it via buffer first. So buffered input stream, then you pass it via the data input stream. It's always this flow, it never changes. No matter whether the question is upside down, whatever way it is, it will never change. Then instead of here, you're gonna say object. This is for reading from objects from the file. It goes in that direction. By that direction, this is what I mean. So you're gonna create a file instance. So file is goes to new file. Then you pass in a string representing the name of the file. Let's assume that our file is factory large.txt, right? So we've established the connection. Then after we've established the connection, we pass that file. You see in what direction it's going. It's going from left to right. So once we're done, we pass that file into a file stream instance, right? So file input stream. I'm going to call it fin, right? Doesn't matter what you name it, or file in, doesn't matter. New file input stream. Then we pass in, because this file, it gets passed into the file input stream. So I'm going to take the file instance there. And you pass this via the constructors. Don't worry about calling methods. Just pass them via constructors. That's the easiest way. Then after creating a file input stream, remember we need to still buffer it. So after this comes the buffer. So I'm going to say buffer in is goes to new buffer input stream. But then what's passed into the buffer is an instance of the file input stream. So fin. Then after buffering it, then now we can put it into the right class that is the methods to read to and from the file, to read or write to and from the file. So which is, if you are reading primitive types, you're going to use data input stream. If you are writing primitive types, you use data output stream. So the format is always the same, right? The only thing that changes here, right? You change input to output if you're outputting. That's the only difference. It's always the same. So there's no need to be panicking and all those things. There's no need really. This thing is easy. This is how I'm going to say data in. Then it's equals to data. Okay, why is it? Do I need to copy that? Data input stream. Then we pass in our buffer. So I've called it buffer in. And then done. Remember, we said we don't have methods to read and write to and from the file, right? Now we have it because we've wrapped it inside a data input stream class. So I can read using this instance here. So that's why when you write our file, we're gonna say data in dot read to read all those things and stuff. So I hope this now makes sense. So before we continue, if you're using ARM, right, you pass all of these inside the square, the round brackets next to the try keyword. You pass it inside round brackets so that it closes those connections once it's done using them. It basically frees the memory once it's done using those variables, those classes, right? Excuse me. So what's the next thing that I wanted to explain before we start? But you see that the code is going to be exactly the same. Yeah, I wanted to explain the different methods. So if you want to read an integer and you want to read a short, you want to read a byte, you want to read double, you want to read float, you want to read, what else is there? There's char, there's a char, right? Yeah, char. But then I'm not going to focus on that. There's also a long. I'm forgetting long. Yeah, I'll just give you a few names, right? Or string. Yeah, let's also put in string because string is quite unique, right? So which methods do we use? I want you to understand something very important about objects, right? The question paper might come and say the file has primitive types and objects. They are trying to test if we really understand streams inside Java. The object input stream, right? It's kind of special. The object input stream and the object output stream, right? It has the same methods that are inside the data input and data output stream, plus methods to read objects. So methods to read, okay, this one is to write objects, right? So it has both. So that means technically, to be honest, technically, right? I'm using the word technically because you might lose marks, but it was gonna work. You can just always use object input stream and all object output stream. If they say there's only primitive types, you only use the section about data input stream because the data input stream, the object input stream class comes with functions from the data input stream and functions from the and methods to read objects, right? So it has both. So you have methods from this and methods to do that. So methods from, and then, yeah, I need to create a PDF of this so that you can always use it as a reference. Methods from that. Okay, let me not save it. I'll just copy and paste it to Microsoft Word and then convert to PDF. So now what methods can we use to read and write? It's to be honest, it's so simple. It makes me just wanna slap someone who gets less than 100. The way is so easy. Listen to the words I'm using. To read from a file, to write to a file, the methods always they are prefixed with read or write. So to read an integer, it's called read int. And all these functions don't take in parameters, all of them. So they're just, you can view them as like accessors and okay, oh no, they're only the ones to read, not the ones to write. So to read an int, you call read int method. To write an int, you use write int. That's how easy it is. But then here for writing, you always pass in the integer, right? To write. We always, they're like setters. Yeah, write. The ones that are prefixed with write, they are like setters because they expect you to pass the thing that you want to write to the file. Then reading, we're just simply reading. So they pass data, it's like accessors. They don't take in any parameters. And they're all the same everywhere. To read a short, there's a read short method, read a byte, read byte, write a byte, write byte, read double, write double. The only method that's kind of hard to remember, not really, but it's kind of unique. There's no function called read string. It's actually called read UTF. UTF, basically the U standing for Unicode, right? So remember, it uses Java uses Unicode. So strings actually they use Unicode. Char data type is using Unicode. The char data type, right? It's 8 bits on C++ and 16 bits in Java. Why 16 bits in Java? Because Java accommodates emojis, Unicode. So you can display emojis and all those things inside your Eclipse. Inside Eclipse, you can do it. Just go and do your research on how to initialize. It doesn't. It's not a feature that's used quite a lot. Then we have write UTF. Then you pass in the string here. The methods are the same to all the functions. They're prefixed to the word read and write. Like I said, this thing is way too easy. Question 2 is the easiest question out of the question paper. So and it doesn't matter which order you answer them. You can start with question 2 to quickly do it, and then you're done. Another thing that I forgot to explain, right? This is very important. If you are dealing with objects, only with objects, with primitive types, it's fine. But if you're dealing with objects, right? Objects. So if you're dealing with objects, they're basically writing or reading objects to or from the file. When you're dealing with objects, that process of reading and writing to a binary file, listen to the word I'm using, a binary file, not a text file. If you are reading or writing to and from a binary file, we call that you are serializing the object, serializing the objects. That's what it means. It's called serialization. Or in other words, once the objects are okay, writing. Let's only focus on the writing part. Yeah, it's writing, not reading. The reading part is, yeah, when you write the objects to the file, we call that, we say that the objects are serialized, or we call that process serialization. Serialization. So in order, like I said, English is very important. Serialization, right? When they are written to the file, they are serialized. The process of writing them to the file, we call that process serialization, which means that the objects themselves, right, meaning the class, needs to be serializable. It's English here. We are playing around with English. If you understand English, you wouldn't struggle at all because everything revolves around English. Whether that's your doing maths or applied maths or stats or comp sci, everything revolves around English. You need to know English. So it has the word able, meaning that you are able to serialize it because we say that the process of writing an object to a binary file is called serialization. And when it's written to a file, it's serialized. So in order for it to be written to a file or serialized to a file, it needs to be able to be serialized. So therefore, we need to implement the serializable interface, which works as like a marker interface. By marker, it's like this, right? This is what marker means, which is English, like marking. When they mark you, I don't know if forgot in high school or even now they mark you, right? So that's what that's what a marker interface. That's its main purpose. So I'm gonna put here and then paste this and then do this, right? Put it there. Then I'm gonna have um this. I think okay, it doesn't want. So let me try this then. Yeah, that's fine. And then I'm gonna need a pen. So I'm gonna choose this. Um, where's that part? Yeah, I need to choose the brush. Yeah, this should be fine. Choose black. Yeah, black is fine. So what a marker interface does, right? It's basically an empty interface. Its purpose is called a marker interface, right? So if you check the slides, the textbook explains better. That's why I always say read the textbook. We have a marker interface. Marker interfaces are basically empty interface. By empty, they're literally empty. So it's public interface. Serializable is one of them. Serializable. It's literally like that. That's what we call a marker interface because its purpose is to mark the class. That's only its purpose. By marking is to tick, as say, it's sort of like an indication to say that this thing is approved, right? So it's like, for example, they look at it, is they ask the question, right? Is it serializable? That's the question. Is it serializable? Then if you implement the interface, it can view it as like it's a yes, like it's a tick to say, yeah, it's approved. We've marked it as serializable. Meaning that now, if I try to write my objects or even, I think even primitive types. Yeah, I think okay, primitive types, you don't necessarily have to, it's the objects. If you're using classes like object input stream or object output stream, you need to make sure that class it implements the serializable interface. Basically, it's marked as serializable, right? So that's all it does. That's why they're empty interface because they don't say the only purpose, they save one purpose to mark the class that it's able to do something. There's also a clonable interface, right? There's another marker interface called clonable, meaning you're able, English, you are able to clone instances of this class. That's that because it's still a marker interface, so it's empty. It's exactly like this one over here. It's literally empty. Its purpose is to mark the class as being able to do that thing. Because remember, interfaces they store what you call abilities, basically the abilities of the class. So it kind of makes sense for you to say mark them as able to serialize and able to clone because interfaces basically store the things that the class is able to do. Basically, it only stores functions because functions they describe what an object can do. So yeah, that's all you need to know there. And I will never touch this again when you do other past papers. From now on, I've explained everything for string tokenizers and patterns and classes, input streams, everything. Now I'll just go straight to the question. So now each session should cover one question, one full question paper. So because you need to do it within 2 hours, 30 minutes. So from tomorrow, we're gonna do those. So by Monday, yeah, tomorrow and Monday, we should be able to, we should be done with those 2024 papers, both of them. So that's basically what it means. So I'm gonna close this. So if you try to serialize, it's gonna crash. Come on, why is this thing of not reading? Don't save. Then let's go back to our code. Now I'm just going to implement. Okay, comparable, right? comparable. You are able to compare objects because you can't compare objects like remember objects are reference type. So if you try to use equals, equals, less than or equals, it's not going to work because you're comparing addresses, basically where the objects are stored on the heap memory, which is useless. So Java came up with the technique to be able to listen to the word I'm using. Java came up with a technique to be able to compare objects, hence comparable, because comparable is it's formed two English words, compare plus able, meaning you're able to compare. So therefore, it makes logical sense to implement a comparable interface, which means that this object is comparable. You can compare it. Basically, you can compare one instance to another. And then type T, right? Type T is the thing that you want to compare. Remember, we want to compare each instance with each other. So that means in type where there's type T, I'm going to pass in the name of that class because I want to compare those two objects. In this case, it's facility. So yeah, now I'm just going to go straight to question paper, right? So let's start. And I did explain something about object input output stream. Yeah, object input, object output, that it has two methods, both from the data input stream and the output stream. So don't be shocked when I try to read integers via the instance of object input stream because they're already there. I did explain that part. So we have this file, this is the file, blah, blah. Don't care about that. Let's create the class, right? So we need to create this class, right? To represent the facility because we're not given additional files. So there's no jar file. So there's no facility class. So let's create the facility class. So facility, and it needs to be in a package. I've almost forgot. xc.factory.model. So I'm going to copy this. So yeah, you see how easy question 2 is. You only create two classes and then you're done. So that's how easy question 2 is. I don't expect anyone to not do question 2. Unless if you're not serious about life. Yeah, you are a special case. So this will be facility. So FACI like this. Does it have a base class? No, this is just binary file handling. So generate comments, right? Then I'm gonna put my comments here at author Vertex Academy. Then at version ST2 2024 ST2 question 2, right? Then there's marks for this. So you need to put it above every single class that you create. Let me rephrase that. Every single public class, because you're allowed to create private or package private classes. You're allowed. But then here you're going to lose a lot of marks if you do that technique because they told you to place them inside their own packages, meaning they all should be public. Then we're going to have, let me also create that class, even though I'm not going to implement anything. So create the new class. So class, then I'm going to change the package name here to that package that I've copied. Then this is called factory file handler, right? Facility, I mean. Then copy this, and then comments, and then done. Don't forget that in order to write to objects to a file, they need to be serializable. So when they give you that hint, you should know what to do. So that's why it's important to read and study. The textbook is the best way. You'll never go wrong with the textbook. So we have item count, right? It means the number of facilities in the file. If you understand when creating a class, what it means, you're not going to do spiritual things. Don't come here and say int item count. Don't do that. Don't do spiritual things. Why would you store item count? Do you understand what the class is? A class is a template, a blueprint of the thing you want to build. You want to build a facility. So you're telling me that each facility has number of facilities, which makes no sense. Does that make any sense? It's like, for example, you have a person class here, and you're gonna have int person count. So you're telling me each person has multiple persons inside of them. You see how stupid you are? So don't do spiritual things. Item count is just stored in the file there. It's item count, right? Remember, it's a binary file. We don't know where we're stopping, where we're starting. So it's always important to they wrote to the file for you so that it makes it easier for you to know when to start, when to stop. So you're gonna use a for loop because you know how many objects are there. So that's why that item count was there. It's only meant for that. But information about the facility is only this. Don't be putting item count doing spiritual things. And the format is going to be the same. You might get exactly the same thing, but then different problem. Instead of a facility, maybe, I don't know, load shedding. It's a load shedding problem, but it's going to be similar. So we have a facility building ID, right? Which is a unique string, blah, blah, blah. We don't care about unique. This is not a regular expression. We don't care about whether it's unique or not unique. That doesn't matter. All you care about is what is it? It's a building ID and it's type string. Notice something. Look at how I'm gonna name my variables. I'm gonna look at the names that they've used here. If you understand English, like I said, English is very important. You see that it's written in a is it not what's that word in italics, right? You see it's written in italics, right? It's curved to signify some importance. So you need to pay attention to that. So I will name it exactly the way it's written here. I'll call it building ID, even the capitalization and everything, the case. I'm going to exactly like that. So building ID. So I'm going to go to my file and I'm going to say, remember private by default. So private string building ID. You see, I don't have to think about how to name. Should I call it BD? Should I call it build ID? You see, I was told how to name the variables. So I'm going to follow instructions. Then I go back to the file. Then we're going to have, what is this? The mode, which is a string again. Remember, two variables of the same data type, we can declare them in the same line. So I'm going to have mode here, just save space. And then we have waste, which is the double. Private waste, double waste, waste. And then private, I think that's an integer, power, right? So we have power. And this will be my instance variables, right? And then you're going to create a constructor, so public facility. So this is not a base class, and it's not an abstract class and things like that. So I don't have to make the constructor protected because I know every class is going to use this constructor. So I'm going to make it public. Then I'll just pass the parameters in the same order as I've declared them. So I'm going to start by building ID, comma string mode, comma double waste, comma int power. Then I'm gonna initialize the instance variables. Building ID, this dot mode is equals to mode, this dot waste is equals to waste. And then this dot power is equals to power. Right, then Java doc. Then I'll zoom out a bit. I'm too zoomed in. Yeah. So that's the parameters, right? Then I'm gonna, it depends on the question, right? It depends. You might need the accessors and the mutators, you might, or you might not. It depends, right? So let's read the question continuously, right? So we have dystopian factories requires conversion of these files into a new binary file format that uses Java objects instead. So basically, they want you to read from this file the primitive types, then write to a file, write them as objects. That's basically what they want you to do. So that means we're gonna have to actually write item, we're gonna write item count again to the new file because item count helps us to know when to stop reading the binary file. If you don't know when to stop reading the binary file, you get an error. So that means your code, it won't compile. It's gonna be kept at 40, right? So item count, the number of objects that are there is very important. So dystopian factories requires item count in a way, right? You can view it in this way. It's like it means how many lines are there. So if I say there's 4 objects, that means there's 4 lines because each line represents one object. So that means I know that I need to redo this process of calling each line 4 times. So that's the importance of this, because if you don't know how many times, that means you're going to keep reading, meaning even 5 times, 6 times, which crashes. So item count, even when we write into the new binary file, we need to write. That's the first thing we write to the binary file. It's important. So dystopian factories requires conversion of these files into a new binary file format. You see, by this part that I've highlighted here, they're basically saying create a new binary file and then write objects instead of the primitive types that were previously written into those files you're gonna read. Then here it says, additionally, they require the contents of the file to be sorted. Yeah, to sort, right? It's very easy to sort. I don't want to lie to you. That's the easiest thing to do. Sorting is literally one line. So you go to the collections class, right? And the collection class, it's like, okay, too complicated to explain that. Wait until you mature and you get to ComSci 3A. Then we'll talk about that. So collections, you're gonna call a method called sort. Like, okay, it's not gonna working here because it's not inside a function or a constructor. So collections, right? Dot sort. There's a sort method there. So sort, we see it takes in a list, an array list. So that means you're gonna have an array list of facilities somewhere. Because how are you going to sort if you don't pass the array list? Because it expects a list. Or remember, list, right, is like a base class. So that means you can pass the base class list and the base class list and and any descendants of that class. So array list is a descendant of list class, so you can still pass it. There's 2 types of them. There's this one whereby it sorts. I don't know how you get. You see, sometimes I feel like slapping students because I don't know how you'd fail. Like it's practically impossible to fail. If you read this part over here, right, it tells you that sorting requires a compare to, meaning the object needs to be comparable. Now you'll understand why in the practice they said it should be comparable, because sorting requires a compare to method. So I don't know how you'd fail to understand this because there's Java talk everywhere here. It explains every function you're calling. So to sort something, you're going to refer to the collections because we're going to most likely going to use an array list or a list. So we're going to refer to the collections class. So additionally, they require the contents to be sorted correctly. The sorting will be done using, if you go down here, we need to make the objects comparable, meaning it actually overrides a compare to method. Sorting calls the compare to method. So that's why they told you to implement the interface comparable, because to sort, you're gonna need the objects to be comparable. So comparison between 2 facilities can be done firstly by, I don't care about that because I haven't started coding yet. So I'm gonna skip the comparison part. Comparison part, they're just telling you what the compare to method will do. So let's start here. Create the facility class that stores required data. I want you to notice something here. They said data, right? Meaning the variables. Remember, variables store data. See, there's the facility class. It has the compare to methods, operations, and implements interfaces and then attributes. So operations, see, operations is listed here, which means you need to actually create the accessors and mutators for each instance. So we're gonna do that because there's marks for that. So it's under operations as functions. So there's marks for that. And then the compare to method is 5 marks. So we're gonna do that. So let me go back here. So there's the class, it implements the correct interface for serialization. If it was me, I wouldn't play around. Me, I'm gonna skip. You see this part over here? I wouldn't even tell you that it implements serialization. You need to know. I'll just tell you the only thing that's important. It implements comparable interface. So that if you crash, it crashes, you suffer. I want those people who are not serious about school to stay behind. I would skip that part. I wouldn't tell you that serialization. You need to know that objects written to a binary file, they're called serialized, meaning the class needs to implement a serializable interface. You would have to know that because it's on the slides. So implement serializable so that the object can be serializable, but then they said you should also implement the comparable. So that means I'm implementing more than one interface. Just like we divide multiple variables by commas, we're going to divide multiple interfaces with the comma. So comma, comparable. And comparable is a generic class. So that means you need to pass in some type T here, some type. Basically, it's the thing that you are comparing it to the facility, which is just the facility, because I'm comparing one facility to another facility. So I'm going to pass facility as the type. Then I need to import serializable. So import. Then I need to include my compare to method, because comparable interface, right? Is this comparable interface? It is a compare to method. So I'm going to hover over this and then click add unimplemented methods. So click there, then error is gone. Then there's the compare to method, because we're going to need to do sorting. So therefore I need to implement a compare to method. Then with my building ID and whatnot, I'm going to ask Eclipse to generate for me. I don't have time to be typing them. I need both because, yeah, they didn't tell you whether the object can only be accessed, the instances can only be accessed or can only be changed. They didn't give you all that information. So just create both, then generate. And then let's see. Yeah, so the structure of a class, right? You always put the methods that you override at the bottom. Right? So you always put it at the bottom. And then in between the methods you override and the constructor, that's where you put your accessors and mutators. That's the odd. So everything is there. Get building ID, set, blah, blah, I'm done with that. So I'll get my marks for operations, right? So the 4 marks for operations, I'll get them. And then creates a blah, 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 blah. Yeah. So let's do the class, right? Let's do the compare. So we need to compare the objects. So the compare to method, that's the method we need to we need to implement. They said comparison, meaning they're referring to the compare method, because the compare method is the one that does the comparison. So they're referring to the compare method, compare to method here. So compare the two facility instances. You see, we are comparing facilities. So that's why I passed the facility there, because the question paper said so. So comparing two facility instances can be done by firstly comparing their waste. So you compare their waste first. So which is the instance waste. And let me teach you something about compare to method. So compare to method, right? If you have, so I'm going to use this and other. So you have this instance, which is that the current object that's calling the compare to method. So that instance, you have an other object, right? So you have two objects here. So you have this object that's on the left-hand side, then you have an object that's on the right-hand side, right? Or that's being passed in the compare to method. So in this case, right, how do I explain this? I think I can skip this explanation over here. I think that shouldn't matter that much, but you need to understand this keyword. If you remember this keyword, it refers to this current instance that's calling that method, right? Basically, we're referring to all instances of that class. That's how we refer them. That's how we refer to them. We refer to them via this keyword. So that this keyword is going to become quite useful. And then other, we're gonna use that to refer to the other object, right? So for example, if I have, let me show you an example. If I have facility, and then I have facility 1 is equals to new facility, blah, blah, blah. Just assume it's instantiated. I don't want to type all of that. Assume they're instantiated, assume it's facility 2 is instantiated. Right? Let's say I want to manually call the compare to method to compare the objects. So let's say I want to compare facility 1 to facility 2. So that means I'm going to say facility 2 dot compare to facility 2. Excuse me. So facility 2, there we go. So in this case, the function, the instance that's calling the compare to method, it's this one. So therefore, this keyword, let me, okay, I can remove this. In this instance, this keyword is actually referring or pointing to facility 1. Then the other instance is pointing to the instance that's being passed inside the parameter of compare to. So this will be other, which is the facility 2. This instance will be facility 1. That's basically what's going on. So I'm going to use this keyword. You'll notice that I'm going to use this keyword in my compare to method. I wanted you to understand that. I'll also call the parameter other so that you see you get the whole idea. So how does the compare to work? It's used everywhere. You can use it on strings, on whatnot, anyway. So it's basically mainly used to compare objects. Because remember, we can compare primitive types. I can have an integer here, and then another integer here, and then I'm going to say A is greater than B. I can compare normally, right? But then objects, they don't support this greater than or less than symbols. They don't support that. They're objects. So you need to, if you remember in C++, we did operator overloading, right? In C++, you have to actually overload those operators so that you can do comparison between objects. Java kind of simplifies that by using a compare to method. So we're going to use a compare to method, which works this way. It returns a 0 if both objects are equal. It returns a 0. It returns a number. Technically, it returns -1, but we're always going to say it returns a negative number, but it's technically -1. So it returns a negative number or -1 when what? When the object that's calling the compare to method happens to be less than that object that's being passed. So what does that mean? When facility 1 is less than facility 2, right? That's when it returns a negative number. So when the object on the left-hand side is less than the object on the right-hand side. So in this case, right, I know it's weird, but try to bear with me and understand, picture it in that way. The instance that calls the method, the compare to method, we can view that as the value or the object on the left-hand side. The one that's being passed as a parameter is the object on the right-hand side. And we are comparing them. So that's why I'm going to write it like this. So when the left-hand side object is less than the object on the right-hand side, then it returns a negative number. Then if it's the other way, it returns a positive number, right? When the left-hand side happens to be greater than the right-hand side. So now this is what we're going to try to achieve, right? To try to do. So let's do that in the practical, right? I think that's the last thing I need to explain. Then now, from now on, we just be coding. So let's implement the compare to method. So we need to compare two instances by firstly comparing their waist. So I need to compare their waist. So let me go down to compare to method. Instead of O, I'm going to call it other object, so that you know that the one that's being passed as a parameter, it's like the right-hand side, which represents or refers to the second object or the other object. So I'm going to literally name it other object so that even if you are blind, you can see it. So remember comparing the waist. So if this dot waist is less than other objects waist dot waist, then we return a negative number, which is -1. Remember, that's what the textbook says. If the left-hand side is less than the right-hand side, you return a -1, right? So I'm going to return -1. Else if we do another check, else if the waist, this dot waist is greater than the other objects waist, if it's greater than, we return a positive number, which is 1. And then if using common sense, if it's not less than and it's not greater than, it can only be equals to. So I don't have to write an else if. I just put an else. So else return 0. Because if it's not less or if it's not greater than, it can only be equals to. Yeah, you can unmute and ask your question. Yeah, whoever raised their hand, can you unmute and ask your question?
Yeah, sorry, sir. I want to ask, what is the object or is the main class?
I can't hear you, man. Before you continue, I can't hear you. I can't make up the words you're trying to say. Can you try again?
Where that's the object where it comes from.
I can't hear you, man. I don't want to lie. Type it down. Just mute and type it down. Just there's a chat section there. Just use the chat section. So let me just show you where it's at. Maybe it doesn't. So there should be a pop-up there on your side. So click there, and then it's gonna take you to chat. Then type your question there. Yeah, let's wait a bit because I don't want to continue when someone is too confused. So I need to understand the question, then we answer the question, then we continue. Yeah, this session is gonna be quite long, not too long, but it should be around 2 hours. Yeah, maximum should be around 2 hours because we're not left with we're actually not left with a lot of things. I'm wasting a lot of time because I have to explain. If I was just writing the code, I'll just go straight writing the code. It will be done maybe in less than an hour. Would be done. That's how quick it would be. But then you guys need to understand, so I need to explain it. Hey, my guy, are you typing? Um, yeah, yeah. It should send me a notification once you're done typing. So let me just continue. So once we're done comparing this, the waste, right? We've compared the waste. I compare this instance's waste, which is basically the instance that is currently calling the compare to method. I compare that instance with the other instance that's being passed as a parameter to this function. I compare their waste variables, right? Remember, waste is an integer, so the less than symbol is valid for integers. So I don't have to worry about that because if you say this dot waste, waste is of type is it int? No, it's double. Yeah, it's a double. So it's a primitive type. So it supports comparison by default. So this is why this won't crash or give you any errors. Don't worry about this return zero, right? Unreachable, we can just simply omit this for now because why do we omit it, right? Why do we remove it? We are accommodating all possibilities. So this function would definitely return some integer. But if I was to remove one of these possibilities, meaning that I'm not accommodating all possibilities, it starts comparing because it says the method must return some type because it didn't accommodate all possibilities. I don't know how they did it, but Eclipse is intelligent enough to read your code and see that no, you're not handling all possibilities because the number can only be less than, greater than, or equals. That's the only three possibilities. So that's why it's not going to complain. Let me see if it did. Yeah, it seems like he's struggling or he's still typing the question. Maybe it seems like it's a very long question then.
It's okay, man.
So
I got
yeah, I wouldn't advise speaking, man. I don't want to lie. I can't hear anything. I can't even make up any word you're saying. So yeah, I think it's a speaker issue on your side. So we're not done yet, right? That's why it's important to read the question. They said comparing the waste. Then, if those are equal, yeah, this question you need to really understand what you're doing. If they're equal, and we said in our here they're equal only when you return zero. So that means in the section for return zero, right? We don't actually return a zero. That's what they're telling you. They're basically saying don't return zero. Do a further comparison. Basically compare again. So you see these three if statements that are here. Do the three if statements again when they're equal, basically when it's equals to zero. So I'm going to need to repeat three if statements in this else part. That's what they told you to do, right? If they're equal, then compare their power because to compare power, remember to compare, we always need to either return a positive number, a negative number, or zero. So that means I'm going to have three if statements again. So under the else part, because I know that's when they're equal, if this instance is power is less than the other object's power, then I return -1 because if they're less than, I return -1. Else, if this instance's power is less than to the other object's power, greater than, I mean, greater than the other object's power, then we return a positive number, which is a +1. Then else, they're equal, right? I just simply return 0. So this is the full if statement. It's weird, but if you understand what you're being told to do, this is the full if statement. So they said if they're equal. So I'm going to check if it's less, if it's greater. This is when it's equal. If it's equal, I do another further comparison, which is comparing the power. That's the full compared to method. So yeah, if you think COMSA is a joke, it's not a joke. Why you goes down? I don't know which warning is that. What's going on here? Did I miss something? Oh, so serialization, I forgot you need to put it. The serialization, right? You need to serialize, right? Each object is gonna need what I call a serialization ID, right? So it's gonna force you to put it. It's not really force it, but warning. You see, it says that it doesn't have a serialized ID. Basically, it's like, remember, we're writing objects to a binary file. It's like yeah, this is the best example I can give you. It's like we're giving each object an ID number so that it's unique. The computer can uniquely identify them. So I'm just gonna use there's two techniques. You can say add a default serial ID, and then you can say add the generated serial ID, which is a serial ID that it generates for you. To be honest, it doesn't matter which technique you use. It doesn't really matter. Just add. So I'm just going to add this one, serial ID default, because in order to serialize, it needs a unique ID so that you can tell them the objects apart. If everyone attended school and we didn't have an ID number, what about those people who will happen to have, I don't know, similar names? Exactly, they have the same first names, middle name, and last name. The lecturers will get confused, right? So that's why each person has a unique ID number to uniquely identify them. Remember, in Java, we're trying to create objects, right? Which is basically things that we're used to in the real world, like a computer, a person. You are also an object. So since you are an object and you have unique traits or things that uniquely identify you, which is via a student number or an ID, even objects, they also need an ID, which is what is called a serial ID, right? So that needs to be there. You can just simply import. You don't have to cram. There's no cramming there. You just simply add it. It will give you a warning. So just to remove that warning, just simply add it. You can add a default one or a generated one. That's up to you. So we understand that part. We are done with the first class, right? So basically, we have all the marks for A and B. No, no, not A and B. Just A. Yeah, just A. My bad. It's just A. Yeah, it's only just A. So yeah, there's still quite a lot to do. So let's not really a lot because we understand streams, right? So I'm not going to explain that. I'll just type the code. So create a facility file handler class. We have that with the following static method. Instructions are very important to follow. Static methods. Read facility data method. So they wrote it in bold to tell you that's the name of the function. Well, that's the name of the method. So I'm gonna copy this name. And they said it should be static. And they said it returns a list. They didn't say an array list. They said a list. They will tell you if it's an array list. So you're gonna lose marks if you use an array list. It'll work, but it's not the same thing. So therefore they're gonna deduct some marks there. They said it's a list, not an array list. So it needs to be accessible. So I'm gonna make it public. So public static. Did they say returns a list of, they said a list of what? Facilities, right? Yeah, list of facilities that we've read from the file. And then it's called read facility data. And you know that it always takes a file handle because that's the only way we can tell Java that, listen, this string, it refers to a file, not a string. Is the name of a file. So file handle, I'll just copy this. That's the parameter that it accepts. I don't want to type, so I'll just import it, paste it there, and then import and import. Yeah, you see, I want you to be aware of something, right? When you use generics, Java, it's kind of weird the way it works, right? You try to hover over facility, it won't show you import. You always have to import the list itself first. So import list first. Then now it will start showing you the import keyword. Then you go over this type, then you now see import. Then you click import. That's how Java works. Since we're going to have to return an array list, that means I need to create an array list inside this function. A list, I mean. I'm going to call it facilities because it stores multiple facilities. And we need methods to be able to add and remove from the facility because we are reading from the file. So I'm going to initialize it as a array list. Yeah, if I have to explain this, it's going to be another, I don't know, not just one session, maybe 2 or 3 more sessions to explain why I can put a base class type there and then I instantiate it to a subclass. But I did kind of explain it some way. I don't remember where, but I did explain it some way. This is a base class, right? This is a subclass. This is allowed because the subclass is a base class. So basically, an array list is a list. So this is allowed. So basically, if you remember that question, you can say reduction area, right? And then say A, and then instantiate it as a specific instance. You can do that because that's Java. And you would only know that if you read the textbook. So go read the textbook. Facilities, semicolon, and then now we start coding, right? Yeah, we'll do one function at a time. So we need to read from the file. So information about the file is there at the top. So there it is. So the first thing I need to read is the item count. But before I do that, remember I need to initialize my file input stream, my what, all those things. So let's do that. So file, since I'm reading, so it's gonna count as input. So I'm gonna use the file input stream. So every function, every class instance I'm gonna create is gonna be of type input. So I'm gonna say file in is equals to new file input stream. It takes in the file handle or our connection to the file, right? And then it's gonna complain and it's around the try catch. It should be file not found exception, right? But therefore the file was not found. But to be honest, you can avoid try catch. But the thing is there's marks for try catch. Let me see if Java will allow me. Remember, I told you that the file class we can check if we were able to connect, meaning the file exists. So I can say handle.exists, right? Then I'm gonna try to create the file input stream, right? Let's try to create it again. Let's see if it's, I'm not sure, but it should somewhat, because we avoid the exception now. I don't know if Java will be, or Eclipse will be smart enough to pick that up. Handle. Okay, it's not smart enough, but you can always do this check to check if the file exists, but it's not smart enough. Let's just leave that then. I thought it was gonna pick it up. So let's use the try catch because it marks for the try for exception handling. So you need to use exception handling. And then here I told you that you don't do this. Output a meaningful name, a meaningful message, right? So you can either call the message method so it gets message like this, or you output your own message. I'll just get the message. Keep my life easier. I don't have to think about what string to output. And then we need to use ARM. You always need to use ARM. It also throws an IO exception. Yeah. So we need to, okay, you're gonna see multiple options here, right? There's multiple options. You can add throws declaration. Throws declaration is a problem because it's going to add it to the function. We don't want that. Add catch clause to surrounding try, right? Meaning there's already a surrounding try catch block, right? We can add an extra catch clause. So that's the option you most probably going to use like this, right? You see, and then it adds to the existing try catch block, right? Then here I'm going to change this to sys error. Then e.get message. No, it's e1 dot get message, right? And then I continue with this. Remember, after passing it from the file input stream, we pass it to the buffer, right? Remember this order, right? After passing it to the file input stream, we buffer it before we pass it to the data input stream or object input stream. So let's buffer it. So buffered input stream. If you're ignoring this topic, right? Second semester, there's still buffering and file inputs. There's still the same thing. So you can't run away from this. If you suffer now, you still suffer again second semester. That's if you make it in second semester. New buffered input stream. So you're not done yet. You don't think you're just gonna cram, pass, and forget. Second semester, do use all these classes. Gonna reuse them again. So file in, and then I need to, the question, right? You need to understand the question paper, right? They told you that it stores only primitive types. So you must use data input because I'm reading only primitive types. So data input string. If they said it had primitive types and objects, then you'd use object input string. So this would be data in is equals to new data input string, which we pass in the buffer. Because since we're no longer going to be reading from back and forth to like since we're not going to be reading back and forth from the file, just be reading from the buffer. It's going to buffer it. Yeah, so we have everything, it's instantiated, right? So now let's look at the question, the file format. It is an item count. And then they said the item count is the number of facilities, which is of type int. They're trying to make sure you pass. They're giving you every detail. It's of type int, it's that, it's called this. I don't even need to think of the name. It's the number of facilities. So I just simply say number of facilities is equals to, then I need to read. Remember, it's an integer. So data in dot read int, because I'm reading from the file. Since I now know how many facilities are there, or basically how many lines are there, now I'll just use a for loop. So int I is equals to 0, I is less than number of facilities, I plus plus, right? Then now I read each object, which is basically one line. Remember, each line is four variables. I have the ID, mode, waste, and so forth. Each line. So I need to read all those things line by line. So let's read them. So for this time around, I don't worry about declaring variables outside. I don't give a damn about that. So I'll just start writing. So we have what do we have? Building ID. So name them exactly the same way I've named it in my base class, in my class. Is equals to, you see, this is a string. So I need to call read UTF function. So data in dot read UTF. And they even tell you you see, they tell you. So I don't know how come people just like failing, I guess. It's a habit. Everything is there. They tell you that it returns a Unicode string. Java uses Unicode. So that's the function that I want, which is UTF. So UTF, which returns a Unicode string. And then we have mode, waste, power, right? So mode, it's a string, then double int. So string mode is equals to data in, which is a string again. So read UTF. Don't use read line. Read line reads the whole line, which is not going to be the thing that you expect. Remember, it's a binary file. It's going to be a line. It's going to be a line full of it is a line full of bits or bytes. So don't use read line. We rarely use read line. I don't know. Maybe you can, but let's not complicate our lives. Technically, you can if it works. I think so. I think so. I don't want to assume, but I doubt. At the same time, I doubt, but I think it can work in a way. I would have to test it out. So we have double. What's the other one? There's power and then what? Waste. So I keep forgetting waste. So waste data in dot read double, because I'm reading a double from the file. And then int power is equals to data in dot read int, because I'm reading an integer. And then I'm done. So all of these inputs, right, that I'm getting from the file, they represent what I call a facility. So I need to add it to my array list of facilities. So I'm going to say facilities dot add a new facility. So therefore I'm going to use give a new facility. I'm adding one facility, right? So facility. And then this facility constructor expects a building ID, mode, waste, and power. And then I'm done reading from the binary file. So I don't know, why would you fail this? You see how simple this thing is? Question 2 is the easiest one. That's the easiest question you can get. Question one is difficult because you have to understand regular expressions, this and that, patterns, remember, toString, it's quite a lot. Main, read three file, it's quite a lot to deal with. Then we're done with the first function right here. We're done with this function or implementing this. Now we need to implement this method called write facility object. So I'm gonna say copy. It accepts a file handle and a list of facilities, right? So let's create that. And they said these methods are static. And they said it writes. They didn't tell about return type, right? So it doesn't return anything. If they don't tell you, excuse me, if they don't tell you what it returns, it means that it returns nothing. It's void. I keep forgetting Java talk for these methods, but I'll put it once I'm done here. So it doesn't return anything. So void takes net file handle and an array list of, or a list, not an array list, a list of facilities. So it's of type facility, and in plural, it's facilities. Then I need to put Java doc for this. Remember, there's marks for Java doc, right? So there we go. Then since we are writing to the file, we're gonna, if you check all of our classes, they're gonna have the word output because we're outputting to the file. So I need to create a file output stream f out is equals to new file output stream. Then it takes in the file handle, and then import, then surround with try catch. You see that everything is in Java. Just import. You just need to remember only a few things, then the rest you just simply import e.get message, right? Then I need to use ARM. Even if they don't tell you, right? ARM is something very important in Java. It's always good. You need to always use it, even if they don't tell you. It's also going to throw IO exception. So add catch clause to surrounding, right? So I'm going to say sys error, and then E1.get message. Yeah, you see that, you notice that's it's very similar reading and writing to a file. The only difference is the functions that you call, and make sure you change everywhere where it says input, you change it to output. It's very similar. Then we need to buffer it. Buffered output, since I'm outputting. So buffer out is equals to new buffered output stream, which takes in the file output stream, right? So to buffer them, then after buffering it, we now wrap it into objects because we want to write it as objects, right? Remember, we want to write it as objects. So I need to wrap it into object output stream because I'm writing it as an object. Then I'm going to say obj out is equals to new object output stream buffer out. So pass in the buffer because we are reading from the buffer so that it makes our application fast. Then I have multiple facilities that I need to write to the file, right? So that means I need to go through each facility because remember, it's called object in singular form, not objects. So don't do spiritual things and try to write an array list. You'll fail. Probably gonna crash dismally. So don't do spiritual things. All these classes are written in singular, meaning one thing. That's why we pass one file here, not multiple files, because it's file output, not files output. Don't be clapped by English and by code at the same time. So I need to go through each array list. There's actually a technique called it's called what? Lambdas, right? So I'm just gonna use lambdas this time around. I'll see if it's not gonna give me issues. It's basically the same thing as a for each loop. So you can say for each like this, right? And then each instance you can, it's up to you, right? You can say facility like this, right? And say E, and then do this, right? To say each facility. But most of the time we're gonna omit this and just use an E or F or facility, whatever you want to do. It's basically the same as a for each loop, but you're calling it on the array list itself. That's a different technique. Then each facility will be stored in this variable E. and then you just simply write to the file. You could do that, right? So I'll just do that. You can do the old school way, right? Like for each facility, and then we are rating it from the array list of facilities. Basically the same thing as this, but I'll just show you, change this to facility so that you see how similar they are. So facility. Then I just write to the file. So to write to the file, remember we're using object out, obj out. So obj out, we are writing an object to a file. Hence, we're going to call the method write object. So dot write object. Then you pass in the object we're going to write, which is a facility. One facility, which is this, right? And then this should throw an exception, right? Let me see, exception. Yeah, okay. If you use an array list, if you use this technique over here, right, you notice something. It's kind of different from a for each loop because you see that you need to declare IO exception again, but then that doesn't, I don't see the problem with that. So you can just know that's how it's different it's going to be. So it's going to be like this if you're using this technique. If you're using the old technique, let's just switch back to the old technique. You can just write it like this because it's already there. IO exception is already there. And then done. So you're telling me that you are failing to write this try catch and getting a 0. Hayi, angizwani nomuntu oslow. Failing to write such simple code. I must send you, I must look for that TikTok. There's 12-year-olds who are building full stack applications. And they're in the meeting, they're in a Teams meeting. They're like, bro, that's easy. Like a full stack application. So yalla cooked if you think you're gonna be lazy around and go to the industry. There's people are working hard. Some are even starting at the age of 12 to code. And it's not like they're special or they have money. Some they even go to the library to just use the computer and code there. And then they go back home. So yeah, don't be like, they are special. Yeah, it's only losers who say that they've advantages. It doesn't matter whether the person is privileged or whatever. You need to work hard to make your life better. Don't always be a person who's full of excuses. If only. If only. What if we get you all the things you need? You'll be like, if only again. You're gonna have another excuse. We get you the laptop. You say you don't have a laptop. You'll be like, no, the rest that I'm in. We get you another rest. You're like, no, this one that I'm in, electricity. You see, always complacent. Nothing is ever enough for you. So you choose, you need to go ponder about your life. Think about what it is that you really want. If you're not serious, I would advise you to go deregister. It's a waste of money. Go start a business or something. Me, I'm not gonna be the type who's gonna sugarcoat and like, don't give up. If it's not for you, my guy, leave, go sell fed cooks or something. In the Java project, create a main class that will serve as the entry point of your program. The main class should use the facility handler, right? Remember, facility handler reads one file, right? It reads one file. So, oh, my bad, I forgot. Almost forgot. Almost small thing that I forgot. Before we write the objects, we need to write the how many they are. So I need to say obj out dot write, which is going to be an integer, right? Int. Then the integer that I'm writing, it's however many these facilities are in this array list. To get how many facilities are there in the array list, there's a size method. So facilities dot size. So that we know how many times we're going to read how many times we're going to use the read object method. So that writing that thing is very important, or else it's going to fail when you try to read from it again. So we need to read all, it's even written in bold, all the provided files. They made a mistake. They supposed to say binary files. So they made a mistake. There's not a text file, it's a binary file. One at a time. First read the file with the read facility data method, and then get a list of facilities, sort the list, then save that list to a new file. So we need to sort that list. So that's why, you remember why I told you that you need to create them of type list, right? Where is it? Yeah. Yeah, you're returning a type list, right? If you check the sort method, it actually expects something of type list. So it's always advisable to use that type instead of its subclass. It's always advisable, especially when it comes to things like lists, right? I don't want to go into why because it's going to take a lot of time explaining that. So I won't go into the why. I've got to put Java doc here. Then put this. Then let's read our main. So I forgot that you can create an array list of all the names, and then you can do all of that to make your code short. So I'm gonna do that. So I'm gonna create an array. You can create an array list too. That's fine. Doesn't matter. Whatever works for you. So names is equals to. Then initialize it to the names in my file. So there's 3 of them. So I need to initialize 3. So what are the files? It's factory large, factory small, factory medium, .dat. And they're in the data folder. So I shouldn't make that mistake again. Data folder, factory small. So this is a small factory, .dat. And then this, then change this to medium, medium. Then you change this to large. Then we iterate through all these file names, right? So for each loop. So for each name inside my names array, then I read because remember this, right? Remember these methods, right? They read one file at a time. So that's why we need to store the file names, then go through each file name and read one to each file at a time and store it into an array list, right? So what we can do, right? You see, this is a very tricky case. What we can do, right? Let's do this. Let's create an array, a list, right, outside here of facilities. Remember, we're reading multiple files. That means gonna have multiple multiple lists or multiple array lists. So we need to group them all together into one array list. So I'm gonna have an array list that's called all because it stores all of them, all of the other array lists. Then I'm going to instantiate it to a new array list, right? Like this. And then I need to import. So this will store all the lists of facilities that we read. Then every time we read the facility, we're going to get back a array list, right? So list facility, so it's going to return a facility, right? We're going to call it facility. And then we need to call the facility file handler class, which has that read method, right? So dot read to read from my file, right? So I need to instantiate a new file instance. Then I pass in the name of the file. So import. So the name of the file that I need to pass here is the parameter needs to be a string, which is the name of a file, which is this over here. So we're going through each name at a time. Then I'm gonna say pass the name here. So it's gonna go iterate through all the names and read one file at a time. But then before I leave the loop, I need to add all. I'm going to use the terminology. This terminology that I'm going to use, you'll see why there's a function with that exact same name. I'm going to add all of these elements in this array list to this array list. So I'm going to, okay, let me use meaningful names. This is where all the factories are stored, right? So all factories, remember this array, all factories array list is empty. We're going to keep adding to it every time we read from the file. So I'm going to say dot to add a collection, right, or a list of elements. You use the add all method because you want to add all of the elements from that list. Then it expects a list, which is facility. Then this has read from all the files and it has added them into this one array list. Done, right? So done reading from the file. So this reads from all the files. Then all of the facilities we found, they're stored inside the all, not factories. Why am I saying factories? Well, it's the name of the files we're reading from. That's what's confusing me. I don't know why these people are not consistent. Why they didn't name the files facility small, facility medium. They always swap them around. I don't know whether they're right in the head or what. Even in the other question paper we did, they did the exact same thing. They named their files differently, which makes no sense. Or maybe they're also confused. I don't know. Then here we need to sort our facilities. It's a void method, right? Meaning you might not you wouldn't understand how it does it, but just know that even if it's void, it updates the array list. So it's a void method. So I'm gonna go to my collections class and I call the sort method. Then I pass the array list I want to sort, which is all the facilities, right? That's the ones I need to sort. Is it all facilities? Is it the one? Did I spell? Is the spelling right? Let me just double check. Yeah, the spelling was not right. So all facilities, then this has sorted them. Remember this, remember we talked about reading the documentation. If I hover over sort, if you read sort, right, it says all elements in the list must implement the comparable interface. It means that we had to implement the comparable interface. That's why they told you in the preg to implement the comparable interface. Because in order to sort, it calls the compare to method. And it does tell you that what I'm finished telling you right now, it does tell you here. So to fail is a choice, especially in ComSci 2A, it's a choice because Eclipse is everything. There's autocomplete for everything. And there's documentation for every class. And then after here, I need to write the sorted objects to a file. So that file, you see that I have factory small, factory medium, factory large. I'm just going to call it factory all, meaning it's all of them, right? And then I'm going to need to write to it. So remember, we have the function inside the facility file handler class, right? And it doesn't return anything. It's void, right? Yes, void. So dot write to, then we pass in the array list we want to write to, which is the array list that is all the facilities. And then we need to instantiate, create a connection to the file. In this case, we don't have the file to write to. There's no name of the file. You can just create whatever file you want to create. Give it your own name. So I'm going to tell it to go into the data folder. Then inside the data folder, create a file named factory. Look for that file. If it's not there, create it. That's what the file class does. It looks for it first. If it's not there, it creates it, especially if you are writing to the file. So factory all dot dat. We're going to use dot dat because it's a binary file, and that's the naming convention they're using here. They're using dot dat. So we're just going to follow their technique. So now I'm going to save all. Then I'm going to show you a technique, right? If we run this project, it should create that file, right? This file over here, it should create it. But then you won't see it inside Eclipse until you refresh the project. So after you're done running the preg and it has created the file, how do you check if it has created it? You don't have to go to File Explorer. You click on the project, you right click, and then you choose refresh. Yeah, you choose refresh. So let me click refresh so that you see that there's nothing in my data folder. There's no fourth file in my data folder. So I'm going to refresh. You see, it's only still 3, right? Now I'm going to run. But then if I run my code, you see that there's no output. I don't like that. So what I would do, right, is that if you've reached here, right, to the last, if you've reached this part and it ran well, that means everything went well. So I'm gonna say C out. You don't have to do this. I'm gonna say successfully wrote to the file, right? Okay, you shouldn't put the output here. Let's not put it here. Let's not put it here. It's the wrong place. So I'm gonna copy this. So cut this and then put it inside the function that writes to the file. So once I'm done writing to the file, basically once the try catch is done here, you can even put it here in the try part. Because once the try block is done, it leaves the try catch block. The whole block, it leaves it. As long as there was no exception that was thrown. So I can just put it here and say successfully wrote the file. Okay, I'm going to teach you some things. Let me also teach you some few functions. What if you want to show the name of the file? So let's say I'm going to say successfully wrote to the question mark. What's the name of the file? You can find the name of the file. The file class, right? Remember, I'm passing a file handle, a connection to my file. The file class is a lot of information. You can get the full path. We can get an absolute path of a file, or you can get a relative path and things like that. So I'm gonna say dot concat, and I concatenate it with the name of the file. So I'm gonna say handle dot get name, which gets the name of that file. So dot get name, then I append that name. Then I also append a dot concat. Then I also append an exclamation mark. You don't have to append the exclamation mark. I'll just put it there, but you don't have to. So it's going to say successfully wrote to factory, blah, blah, that name to this. But then I think this is not the get name. Yeah, it's not perfect. Let's check the documentation. It's not perfect. It returns the name of this file or directory denoted by this abstract path name. This is just the last name in the path names name sequence. Okay, yeah, I think it won't. I was thinking it was going to include the word data, because remember we said go to the data folder and that. I think it will only extract to this actual name. So let's run it and see. So let me expand this, then run it, and then bam, you see there's the file name. Successfully wrote to the factory all.dat. So it works perfectly. Then I'm gonna click here. You see that it doesn't show the file. So you think it didn't work. You always have to write, especially with file handling, writing to files. You always refresh in Eclipse. Then I right click on my project and I click refresh. And then there's the file. And to give you okay, let me give you a simple hint on how to know if it wrote successful to the file. This output might be misleading. Maybe it didn't write well. I noticed something here. I noticed a pattern. Let me show you. Basically, we're done with the paper now, but I just want to show you this quick thing, then we end the session. So if we go inside here, then open Eclipse Workspace, Vortex Academy question 2, yeah. There it is here, and you go to data folder. You notice factory or right? Try to add the size of all the three files. You see that they add up to the size of the new file. 2 kilobytes plus 1 kilobyte, that's 3 kilobytes. Plus 1 kilobyte, that's 4 kilobytes. So therefore, I know for a fact it wrote all of them, because the size of all the files, they add up to the one file. So that's how in my own way I can conclude. Just a simple hint to check it, a simple confirmation to check if it does add up, right? It did add all of them, and I can see that it did add all of them. Then you can right click and open, but this is a binary file, so it's not meaningful. You see, it's not really meaningful information. But if you try to read carefully, some parts you can understand. You see, there's building ID here, which is a variable, right? Then there's some of the IDs. You see, this is actually an answer for a variable. And then I think so. And then there's some other ID, if I'm not mistaken. Yeah, these are all, yeah, you can somewhat read the binary file, somewhat to an extent, certain extent. Yeah, so that's basically everything. That's all you have to do. If you notice something, this code is actually, do you see how way shorter it is compared to question 1? This is way short. Remember, question 1, you also have to do UML. Question 2, I'm not sure about UML. I don't see it. Let me just double check, but I don't think there should be UML for question 2. Read all. Yeah, there's no UML. So question 2 is the easiest question you can do. So yeah, so you can't complain about question 2 now. Excuse me. So yeah, that's it for today's session. I'll zip and send you the code in the group. And then just wait a bit for the recording to save, right? It should take, since it's 2 hours, maybe it should take 10 minutes to 15 minutes to save, the recording to save, then I'll send it. So see you in tomorrow's class. We're gonna have a session tomorrow because you guys are writing, so we need to cover everything. I don't know if you can have a session in the morning and then an evening to cover 2 papers in one day. Because like I said, from now on, I'm not gonna explain anything. I'm just gonna solve the question. There's no encoding, what is output stream. I'm not gonna explain nothing. I'm just gonna write the code now. So we should be able to do 2 papers in that session. So let me stop recording, then see. Goji, someone had a question. Let me stop recording. Yeah, you see, I wasn't lying. We were supposed to limit it to 2 hours because I had 2 hours because I was